Hi, everybody. With me today is Dan and Tomas. And what we're going to do is go through OpenConfig. So this will be part of a multi-part series, but we wanted to start off with an intro to OpenConfig, what it is, how it works. And with that, I'll hand it off to Dan.
All right, let's share my screen here. So I'll be doing most of the hand waving and explanations and such and so forth. And my co-pilot here, Tomas, will do most of the demo intros and such. But OpenConfig in general, most people are going to take a look at this and kind of see the forest for the trees is a rather good expression when it comes to OpenConfig. So there's a lot of information out there, but it's typically kind of tough to kind of go through if you're new to this to really understanding a lot of it. To define OpenConfig, it's right directly on the website. It is an informal working group of network operators sharing a goal, moving towards more or less dynamic, programmable intent data to describe a device. Now, this intent data typically works across any platform that has an OpenConfig interface, and we'll kind of get back and forth to that. Through the OpenConfig website, which is largely operator-driven, open, and for the most part easy to navigate through, they have the repo for the OpenConfig, Yang models and so forth. And you can even subscribe to working group and such. But from here, from the OpenConfig website, it makes it a little difficult to kind of navigate the waters and what's available and such. So us three here kind of took it upon ourselves to create a repo for a lot of the Arista EOS platforms to typically tell like what use cases you could do, how to configure OpenConfig, how to use it, and just a lot of really good information about it. If you go to this repo, which is here under the Arista Networks repo under Open Management, you can see a lot of good stuff here. We do have this in what's called Markdown, which is going to be a web page portion you can go to and click on it. Links will be, Fred will provide links as well, but just go directly into GitHub pages. You should be able to view the deployment for each one of these, and it'll bring you to this beautiful, awesome Markdown in which you can go through and quickly navigate into each one of these. Now for this web series, you want to call it, we're going to go through a lot of configurations. So configuration is very simplistic on Switch. Tomas is going to kind of show back and forth how that works. Different protocols involved OpenConfig. Because a lot of times OpenConfig, like you'll read about these different protocols, whether it's going to be, like losing my train of thought here, gRPC gNMI, which is a service that runs on it. We're going to specifically focus on a lot of that. We're going to specifically focus on a lot of streaming data back and forth of these models, where it just makes a lot of sense to do that. We're going to talk about netconf a little bit back and forth, and then restconf as well. Those are typical protocols you use. We'll go through a lot of the tooling because a lot of this data is really, really valuable for a lot of network operators, and just streaming back and forth the state of the device and make sure that the intent is always the same. Telemetry, like I said before, big thing with this, and just overall examples and how to use this. Like we'll go through a couple tools are open source via like Netflix, for example. We'll go through how to use this with Telegraph, Influx, Grafana, all those really, really cool things. But all these examples are here within the repo, but we'll spend most of our time talking back and forth between this. But just the overall example of really what OpenConfig is just a data structure. That's all it is. Go across any different one of your platforms. So any one of those platforms with netconf, restconf, gNMI, gRPC, it's just a way to describe like exactly what that platform is and the intent in which it has, which sounds like a lot to take in, but as you kind of go through the series of how things work, it'll make a lot more sense.
So if you can hang on, if you could kind of back up for a second, like what's the motivation for OpenConfig? Like why would you use OpenConfig? What prompted the network operators who are part of the OpenConfig group to actually start this over what's out there before OpenConfig?
So Fred, have you ever used SNMP before?
Yeah, painfully.
So yeah, that's typically it. So SNMP, you look at the RFC for that. I think it's been around since maybe
the dawn of time.
Yeah, maybe Tomas might be, you might be older than SNMP. I don't know. Or younger than SNMP. I'm sorry. But generally with SNMP, like you typically, most people who use it don't like it. Doesn't support streaming, bulk transfers, that sort of thing. Here, this will work across everything, and you could stream it back and forth as we kind of go in and forth and use it. But the motivation is to create like a service or a data structure that you could blast across any device that supports it, more or less for streaming or configuration. But a data structure works across everything, a single model that can be applicable to anything that supports OpenConfig. It's mainly operator driven.
So when you say anything, you mean anything, meaning a network device, like a multi-vendor network, any multi-vendor network device. So you could talk to an Arista switch, you could talk to a Cisco router or a Juniper router or various other vendors and devices that are kind of network-based devices.
Yeah, that's the dream. That's the idea of OpenConfig, is that like you have certain paths within the device that specifically say what they do or what they function or are. And, you know, not to use the intent word, but, you know, that intent would match whether it's going to be any device, whether it's an Arista device or any other vendor that supports one of the OpenConfig transports. Everything should roughly be entirely and exactly the same. So whether you're configuring it based off a path, or whether you're trying to ask a device, hey, like, do I have X amount of BGP neighbors that are supposed to be configured? My interfaces, are they streaming the right counters? As long as a device supports those models, the intent-wise should be the same across any device that actually supports that OpenConfig transport.
Cool. So what are we going to go into first here?
So I think Tomas is going to blow everyone away with a quick demo of just gNMI and so forth, I would imagine. All right, Tomas?
Sure. So let me, can I share my screen or?
Yeah, let me stop sharing here.
Share mine. All right, so it's super simple to configure gNMI on EOS. It doesn't matter what, if you have a switch or if you have virtual EOS or cloud EOS or containerized EOS, all of them have the same configuration, and you can find the config examples on this cool website that Dan has presented previously. So if you go to the configuration bit, you will see that there's some overview, and then it talks you through how to configure it in various scenarios. And it is as simple as just going to global config mode and typing management API gNMI, then create your transport, which you can name whatever you want. And then you can also enable it in a VRF if you're running it in a VRF. And you can also change the default port, which is by default is 6030, or you can also add an ACL and deny or permit specific IPs. So
Tomas, what exactly is gNMI? I mean, so we talked about OpenConfig, what it's for. What is gNMI's role in this, or you know, what does gNMI even mean?
So gNMI is the gRPC network management interface, which it used to be called OpenConfig, and now they have renamed it to gNMI. And basically, it's the latest management protocol that people can use across multiple vendors to get, subscribe, and change data on the devices using the same paths, which makes it super easy to implement it in a multi-vendor environment. As every vendor would just create their hooks in the backend to the standard gNMI paths, which is defined by the OpenConfig open source team or consortium. And so that way it's very easy to check the states of any switch in your network that supports gNMI.
So would it be appropriate to say, I guess, so gRPC here is the transport. So that's like you're using that instead of, say, HTTP or something to actually send your requests across and receive data back. But then gNMI defines the API structure on the other end?
Correct. Yeah, we use gRPC, and we use the gNMI protobufs. So basically all the data is encoded in protocol buffers, and the data inside can be then encoded in either protobuf or JSON IDF.
Cool. Thanks.
And so let me show an example. So I have my switch on the right-hand side, which has gNMI running, and I can also check that by running show management API gNMI, which tells me various information. If Okta is enabled, which we'll get there later on, in what VRF it is running, if the service is enabled or not. And then it tells me on what port and what VRF it is running again, if there's any SSL profile, and if there's a QoS or authorization required. So now I know that my service is up and running, so I should be able to get data from this device. And there are multiple ways of doing it. You just need a gNMI client, and in this demonstration we'll use gNMI-C, which you can download from their official webpage, gnmic.kmrd.dev. Following the installation instructions is basically just doing a curl on this web page and running the command, which we've also included in our examples page. If you click on examples and then go to gNMI clients and then go to gNMI-C, we have an example on how to download and install it. So once it is installed, you just have to formulate your command, which would be to specify the address of the switch, which would be the IP and the port. And by default, it's port 6030, as I mentioned. And then you can specify the user and password. If you're not using certificates, then you would also need to specify -- insecure. And then after that, you would specify your action, which could be get, subscribe, or set. And in this case, I'm doing a get on the interfaces path and looking for the operational status of all my interfaces. So if I run this command, it should give me the operational status of all my interfaces, and we can then compare it with the actual show command. So I have, let me make this a bit bigger. I have 8 interfaces, and all of these are up and running. And I have the same on the OpenConfig side as well.
So you mentioned you could do either a get, a subscribe, or a set. So we saw the get here, right? You just basically fetch the data from there. What do the subscribe and the set, what would those allow you to do?
Yeah, so let's check out the subscribe one. With subscribe, you basically can subscribe to paths, and you will be able to get information real time from all of these. So let's see what happens if we subscribe to the operational status path and if we shut down one of our interfaces. We should get a new update. And yeah, we got a new update instantly. As soon as I typed in shutdown and hit enter, I got the state on my client. So if I unshut it, then I'll get the state instantly as well that it has come up.
Very cool. So this is kind of back to Dan's point about how this differs from, say, SNMP or something that we're used to using, or even making REST calls. We can actually get streaming push notifications from the device whenever state changes versus me having to constantly pull the device and see whether the state has changed.
Yeah, and we'll get into more of this as this goes on. There's a couple different ways you could do it, sampling on change, and there's another one I'm missing. It's come to me later, probably when we're done. But yeah, typically it's going to be a stream data, like it's going to stream it to the client in this case. So obviously with SNMP and so forth, you do tend to miss things, which is unfortunate within that polling data interval. But yeah, if you subscribe to something, this will give you everything. But the real, like, really good part about this is we're just using the gNMI client. But if you weren't and you're trying to push this data to time series, pushes data to some kind of database and then further graph it or use it for some kind of tooling, you have so much data that's available to you that's just kind of streamed back and forth, which is pretty much incredibly nice and something that is difficult with things like legacy ideologies like SNMP, where you would miss that data. This you're getting practically everything, which is very nice.
Yeah, exactly. And there's you can also change the configurations on the devices. For example, if I want to change the description of my interface, I can just reference the path for that interface, which would be like /interfaces/interface. In the bracket, you would define your interface name, and then /config/description, and then you can specify the update value, which you want your new description to be in this case. And I think that should update the description. So if I check the config, you can see that it has been updated to Grogu. And before it was OpenConfig _test22, as we saw in this show interface status.
Before it was Baby Yoda, now I get renamed.
Yeah. We can we can make it Yoda now.
It grew up.
It grew up and got more midichlorians.
Very cool. Okay, and so I noticed you guys both kind of keep talking about, and you're showing here this path. So I guess that's how you get to the specific thing that you want to query on the device, right? I mean, to make a bad analogy, it's almost like your SNMP MIB kind of thing. But yeah, this is how you kind of drill down. So how would you know what path you want to go to? Let's say if you're trying to, for the first time, figure out that you wanted to get to the description of this interface, like is there a way to figure that out?
Yeah, we'll get more into it later on, but yeah, I totally agree with you. Typically in SNMP world, it's what's 1.2.5.7.9.10.12.
Right.
It's not exactly readable to the human eye. These come from a Yang model, a Yang schema, and basically there are different tooling you could use to find out a lot of this, whether it's PyYang or GoYang. Also for the path repo we provide publicly. So you can go to any version of EOS code. Yeah, you're gonna click on 425.2f, and we show the supported paths and what leaf lists, what's rewritable, what's read-only, and that sort of thing. So hopefully we can click on this here and find out. But typically what's gonna happen is, and that's the other thing too, we'll dwell on a little bit in the future, is these different paths relate to models, which are on the switch, and then different versions of code support different types of models. So this is a good way for the human eye to be able to actually read like what paths are actually supported. And we'll get into leaf lists, leafs, what's readable, what's writable, what are augments not supported. But this is a really good way for human readable ways of finding out all the paths that are available. The other thing too you could do is just for a quick, Tomas, you want to jump back in your IDE there and just do a quick get for like just /.
Yeah.
That's a good way too as well. All right, so yeah, Tomas, you can go ahead. Yeah, there you go. Do the get, we can grab all the information that's within on the switch. And all this big, beautiful JSON will kind of give you everything. So, the ways of going through the path support's really good without having to do anything. And also too, like this will give you all kinds of stuff. And we'll talk more about this too. Like there's OpenConfig model, not to dwell upon a lot of this. There's OpenConfig models, there's experimental models. There's all sorts of really good stuff that we'll go through this series and explain a lot, because there's just a lot, there's a wealth of information. And that was our real motivation for this series and also for that repo for our site. But this will be good for someone getting started in OpenConfig and taking a look around with all the examples. It'll resonate very nicely with someone who's wanting to jump into this field.
Very cool. Yeah, so I think that's a great place to stop for this first video. We'll put a link to the repo and to the GitHub Pages site in the notes of the video posting, and we'll see you guys next time. Thanks, Dan. Thanks, Tomas.
Thank you.
Thank you.